Welcome to GTC, and thank you for joining us today. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. All the windows on your screen are resizable and movable. If you have any questions during the webcast, you can submit them through the Q&A window to the right of the slides, and we'll try to answer these at the end of the event. A copy of today's slide deck will be available in the GTC session catalog. You can find additional answers to some common technical issues located in the Help widget at the bottom of your screen. An on-demand version of the webcast will be available approximately 1 hour after the webcast and can be accessed in the session catalog. Now, without further ado, we'll turn the event over to our speaker to begin the presentation.
Howdy, folks, and welcome to Deploying and Managing Applications at the Edge with NVIDIA Fleet Command. My name is Troy Estes. I'm a product marketing manager over here at NVIDIA, working on Edge and enterprise solutions. For those of you based on the West Coast of the United States, good morning. For those of you who are not, good afternoon and good evening. But most of all, thank you very much for joining me today. What I want to do is talk to you guys a little bit about what the Edge is, what some of the benefits and challenges are for managing and deploying artificial intelligence at the Edge. And then, of course, I want to spend some time talking about how NVIDIA fits into that picture and some of the tools that we have to help get artificial intelligence successful at the Edge. We're going to have a Q&A session at the end. I'm going to be joined with a couple of product managers from our team. So if you have questions throughout the presentation, I encourage you to use the Q&A module, and so that we'll be able to get to all your questions and hopefully clear up anything that you might be confused about. Without further ado, I think we can jump in here. The first thing I want to do is set some context for the different waves of the AI revolution that we're seeing. And hopefully that will give you guys some information about what has led us to the point where we think Edge AI is sort of the next wave of the revolution that we're going to be experiencing. So right now, artificial intelligence, it's pervasive. We see it sort of every day. And it's quickly becoming part of our everyday life. From recommender engines to text-to-speech modules, every organization is looking to adopt artificial intelligence. And seemingly mundane tasks that you and I complete every day are affected by artificial intelligence. This could be looking for a new television show on Netflix, or this could be going to a shopping mall when people still went to shopping malls. But what was once confined to the data center for research is moving closer and closer to the end user. And this happened first with cloud AI, really. And then this is the next wave of this is the Edge AI. And Edge computing solutions hold the computing power directly at the location that the data is collected, therefore reducing the time it takes to process the data. And this is in contrast to cloud computing solutions, which, of course, do all that processing in the cloud. And with increasingly large data outputs from sensors, though, cloud computing platforms struggle to operate fast enough to generate real-time insights. And this leaves organizations unable to quickly adapt to changing conditions where artificial intelligence is deployed with the end user. And for some systems, such as those in hospital rooms or robots in factories, delayed insights results in unsafe conditions. So Edge solutions, however, can act on inputs instantaneously and improve user experience and deliver value faster. So as we're talking about Edge and thinking about Edge, hopefully this provides good context for you. But I want to talk about this a little more because the reasons for switching from cloud AI to Edge AI are quite significant. So I want to spend a little bit more time building the context for that. So really, we're experiencing a once-in-a-lifetime intersection of three major trends. The confluence of 5G, IoT, and artificial intelligence has started the next phase of the digital transformation. And this new wave enables new use cases to transform every single industry. And we're all witnessing those changes right now. So it's expected that there's going to be over 1 trillion IoT devices by 2035, or just over 100 IoT devices per person on Earth, which is crazy to think about in terms of the scale. That many devices, it's 100 devices per person on Earth. And that many devices enables so many different use cases if you think about how they're going to be able to affect technology. But that many devices also collects a massive amount of data. And even now, billions of IoT devices are providing organizations access to an unprecedented amount of data. And 5G is enabling the new connectivity fabric designed to handle the explosion of those devices, of those IoT devices, by replacing Wi-Fi with faster and lower latency connections. So with that many devices generating data, the only way to process that data in real time is by placing servers near the point of action and using the immense computational power of GPUs to accelerate artificial intelligence. By doing this, we bring the processing power from the cloud to the location that the data is being collected. This greatly reduces the latency for generating insights, and this process is what we mean when we refer to edge computing. So what are the use cases for edge, though? Really, it's situations where you need zero latency and rock-solid reliability. So the use cases are actually quite expansive, from artificial intelligence in smart retail shops or retail shops aimed at preventing shrinkage, to manufacturing warehouses using AI to optimize throughput and protect integrity, to smart traffic lights using AI to create more efficient cities. I mean, it can really be a lot of different use cases depending on how you're interested in implementing artificial intelligence. But the one thing that all of these use cases on the screen have in common is their need for real-time insights. Data is only as good as the insights it provides. And if insights are generated in enough time for real-time decisions to be made and to be actioned, then organizations can easily adapt to those changing situations. And we would consider this an artificial intelligence success if an organization is able to receive insights in real time and make actions to react to a situation happening in real time. So take, for example, the idea of an autonomous forklift. If a forklift detection system, their perception system, experiences high latency, it might not be able to perceive an obstacle in time and might create an accident in a facility or a warehouse. And of course, organizations are hoping to use AI to mitigate this challenge and to solve for other use cases as well. So basically, any situation that involves AI and IoT devices where accelerated insights are needed to drive real-time actions is the perfect use case for edge processing. But it's not just the use case. As mentioned before, it's also about the scale of devices that you need to take into account. So if you're thinking about artificial intelligence and you're thinking about the edge, one part of it is thinking about your solution and how your use case plays into the need for edge versus cloud computing. But then it's also the scale of your solution and what that deployment model looks like also practically, and then what sort of your dream model deployment looks like as well. So to talk about the scale a little bit, there are 2 million factories, 13 million stores, 12 billion acres of farmland, and 40 million miles of roads that need to be constantly monitored. And these millions of endpoints need to operate in real time. They need to be orchestrated from the cloud, and they need to be secured for edge operations. And without achieving those 3 goals, operating in real time, orchestrated from the cloud, and secure, then operating an IoT application on a large scale becomes costly. Securing large-scale IoT applications is patchy at best, and having visibility into the edge infrastructure is almost impossible. It's extremely difficult. So that's where NVIDIA comes in. NVIDIA EGX is the cloud-native platform that dramatically accelerates inference at the edge and lets organizations harness rapidly streaming data from factory floors, manufacturing and inspecting lines, city streets, and many other use cases to securely deliver next-generation AI, IoT, and 5G-based services at scale with low latency. So EGX is a major component of NVIDIA's edge strategy. So as I go throughout this presentation and you hear me mention EGX, to you, that should mean that that's what NVIDIA is doing at the edge. So on the left here, you see a diagram of what our edge stack looks like as it relates to EGX. So I want to jump into this a little bit and take a closer look. So let's start at the bottom of the stack here with the gray box, the EGX server. This is our NGC Ready for Edge hardware system. These are systems that are built by OEMs and have been validated as performant for AI and have been validated to provide remote management and added levels of security. So this is the sort of bare metal platform that we have validated for artificial intelligence and have validated for security, which is huge for us. And we have a ton of partners that we work with here from the OEM side. They include Dell, Lenovo, Atos, HP, and many, many others. Just above that layer, the EGX stack, the first sort of green box we see there, the EGX stack is NVIDIA's cloud-native software stack, and that provides a robust, resilient, and secure computing platform. It's available either for self-managed solutions or integrated within enterprise-grade solutions like Red Hat OpenShift, which are at the heart of the EGX platform. And again, we have a vast ecosystem here at this level of the stack, and that includes VMware, Canonical, Cisco, and a lot more. The next layer above that, the CUDA-X platform, for those of you who don't know, NVIDIA CUDA-X, it's built on top of CUDA, and it's a collection of libraries, tools, and technologies that deliver dramatically higher performance than accelerates across multiple application domains, from artificial intelligence to high-performing computing. So it's sort of a critical layer if you are considering artificial intelligence at the edge. And then above that, we have our application frameworks. So the NVIDIA application frameworks provide tools to developers developing AI solutions for a variety of different industries. We have Metropolis for smart cities. We have Clara for healthcare. We have Metropolis for smart retail as well, Isaac for robotics, and then Ariel for telco. So if you're on this call and you're an application developer or you're an ISV and you are using our application frameworks, then you'll be using them to help you build your artificial intelligence solution. And if you're an app developer or an ISV on this call and you're not using our application frameworks, I encourage you to investigate those, because I think you will find the tools there and the knowledge that's provided very helpful for you to be successful in your solution. And then at the top of the layer there, we have NGC. And NGC is NVIDIA's registry of turnkey AI software solutions composed of application containers, models, model scripts, and Helm charts. And it leverages NVIDIA's vertical frameworks like Metropolis to build solutions for smart cities or work with leading ISVs that call the NGC registry their home. So this is sort of a comprehensive idea of what sort of our stack looks like for NVIDIA at the edge. So as I'm going through this presentation, hopefully you have an idea of what NVIDIA's solution looks like in context of inference at the edge, which is what I want to get into next. So this is a cool diagram that shows how the NVIDIA EGX platform in action fits into the edge computing flow. So on the left here, we see the various IoT sensors collecting a ton of data in real time. These are all the use cases that I mentioned before. So this could be a retail store, a hospital, a smart city environment, or a warehouse facility. And they send that data to the EGX servers at the edge. So the servers are installed at the edge location, and the data is sent to those servers. And those servers are running the NVIDIA secure software stack, which then returns recommendations and insights back, obviously processing the information that it's getting from those sensors. And then on the right, we have a cloud platform service at the edge, but we'll get more into that in a minute. But to summarize the benefits of edge computing, it really comes down to bandwidth and latency. And I know that this is a technical conference, this is a developer conference. So I do actually want to get into the weeds for a second here and describe why latency is so important for edge computing. And that's because there's a tangible round trip time associated with API calls to remote servers. And applications that demand near instantaneous inference cannot function properly with the latency associated with remote servers. Take self-driving cars as another example. A large enough latency could significantly increase the risk of accidents. This is a similar example, as I mentioned before, with the autonomous forklift. Moreover, when you have a large number of devices connected to the same network, the effective bandwidth is reduced. And this is because of the inherent competition to use communication channels. And this can be significantly reduced if computation is done at the edge and doesn't clog those communication channels. So take the case of processing 4K HD videos on multiple devices. Processing them locally would save heavily on bandwidth usage. And this is because we do not need to upload the data to the cloud for inference. And due to this, we can scale the network easily. So the benefits of the edge computing are quite significant compared to cloud computing for a lot of different use cases as it relates to artificial intelligence. But of course, there are some unique challenges with edge computing as well. So edge systems dispersed across a landscape, if you're thinking about if you have multiple locations, maybe a dozen factories, it lacks the data center physical security infrastructure that IT takes for granted. Edge servers need to be designed to be self-secure and easy to update, manage, and deploy and maintain from afar with guaranteed zero downtime. That's one challenge. Additionally, as AI becomes pervasive in computing applications, so too does the need for high-grade security at all levels of the system. Security needs to be integral into the AI process. The protection of AI systems, their data, and their communications is critical for user safety and privacy, as well for protecting businesses' investments in these artificial intelligence solutions. And lastly, of course, edge nodes add another layer in the IT infrastructure, so it's imperative for admins to manage the workloads at the edge level in the same dynamic and automated ways as one would with on-premises or cloud solutions. So that's why NVIDIA has taken a cloud-native focus to our edge solutions. So these are the requirements for organizations that are looking to deploy edge solutions and are looking to build out their deployment plan for their AI solutions. And NVIDIA is addressing these with EGX Stack as well as with our next tool that I want to talk to you guys about, which is, of course, NVIDIA Fleet Command. So NVIDIA Fleet Command, it was announced this week. It's a hybrid cloud platform to manage and scale AI deployments across dozens or up to millions of servers or edge devices. Fleet Command allows IT departments to securely and remotely manage a large-scale fleet of deployed systems. So instead of spending weeks planning and executing on deployment plans, in minutes, admins can bring artificial intelligence to networks of retail stores, warehouses, hospitals, city street intersections, really any of those use cases. Administrators can add or delete applications. You can update software over the air, and you can monitor the health of devices spread across vast distances from a single control plane. So NVIDIA Fleet Command is a centralized control plane operating in the cloud. And from that cloud browser, you can provision devices, EGX servers at the edge, as I mentioned before. You can provision those with one touch. And then once Fleet Command is paired with those provisioned devices at the edge, it becomes extremely easy to securely deploy, manage, and scale AI across your entire server infrastructure in minutes. So that's the tool, and it's actually quite remarkable. And what I want to do is dive into a diagram here to help show you guys what that looks like. So on the right here, it's a diagram of what Fleet Command is and the various different components that are part of it. So Fleet Command, so it hosts applications in a public or private registry, and these exist in secure containers. So you can see that happening on the left here in the cloud. We have the private registry, and you're able to have your application lifecycle management from the cloud too. So with Fleet Command, users create locations and systems in Fleet Command. And then using one-touch provisioning, the systems that exist that you've created in Fleet Command are paired with EGX servers that exist at the edge location. So now in your Fleet Command console, you have the systems that you've set up, and those are paired to physical systems that exist across your entire edge infrastructure. So it could be dozens or hundreds of systems that you set up. And then to create a deployment, you choose a location which has systems associated with it, and then you choose an application, and then boom, with just a couple clicks, you put those together, and that deploys your artificial intelligence application to those locations and systems that you've set up. So it's very simple. With just a few clicks, you can scale AI across your entire infrastructure and manage all of your artificial intelligence solutions. So there's three major benefits that I want to touch on to drill into you guys what the value is of Fleet Command in your AI deployment infrastructure. So the first, of course, is effortless management. So managing AI at the edge is really time-consuming and expensive. With dozens or evens of millions of devices to install and maintain, organizations need the ability to deploy and manage and scale AI across their entire infrastructure using one tool, and that helps them greatly reduce the costs associated with edge infrastructure. Of course, Fleet Command centralizes the management of all these fleets and devices. So streamlined provisioning, detailed monitoring dashboards, extensive automated processes, all these things allow IT, DevOps, system administrators of any skill level to manage the deployment and maintenance of AI at the edge. And this is unlike manual deployments or CLI-based tools, which normally require a fairly high level of technical acumen to accomplish successfully. Fleet Command orchestrates all of the deployments by allowing users to easily choose which locations AI applications should be deployed to. And then managing AI deployments from a central location allows for over-the-air updates, remote debugging, and system monitoring, as well as other features, which makes the life of system admins a lot easier. Access to remote management features means that maintenance and upkeep is easier and reduces cost, and therefore making AI more accessible and practical at all locations that are difficult or far away from resources at headquarters. So if you think about the normal process for deploying artificial intelligence at the edge, if you have a dozen facilities, normally you would need to send an IT administrator to each of those facilities to deploy the artificial intelligence and update software, or if a system goes down, they would need to go to repair it, which of course takes time. And if a location is particularly remote, it might take so much time and money that you just decide to not deploy artificial intelligence to that location. But if you have all of that management in the cloud, then deploying artificial intelligence and maintaining it becomes a lot easier. And so therefore, you have the ability to deploy AI to all your locations, because you know that you don't really need to worry about managing them in the same capacity that you needed to before. And then, of course, security is the other main proposition here. So, of course, unlike manual or CLI-based tools, NVIDIA Fleet Command actually has a lot of security capabilities built in. And this security is end-to-end from the cloud all the way to the edge. And this ensures that the intellectual property and application and sensor data are always protected. And Fleet Command deploys applications from the NVIDIA NGC Software Hub, and applications hosted in NGC are scanned for vulnerabilities and malware before they're loaded. In addition, users can sign containers to ensure that only authenticated software is run at the edge. And at the edge, all process data is encrypted at rest, and the AI runtime is protected from tampering with secure and measured boot. So because systems are on premises to process local sensor feed, organizations maintain control of where their sensor data is stored. They're able to maintain that entire process. So I actually have a security slide after this, so I want to leave it there, and I'm going to jump into security in a minute because I want to deep dive into that. But the last thing I want to talk about on this slide is resilient software. So with many devices and many locations, organizations need resilient software to streamline management. Without resiliency, organizations face the incredible challenge of having to manually repair remote systems when applications fail. And this leads to long periods of application downtime when insights aren't really being generated and they're not really being processed. Fleet Command features a resilient software stack and allows all systems to heal when applications are disrupted. But resiliency means more than just infrastructure that can restart applications. It also means workloads can be migrated to reduce application downtime. If a system is disrupted at one location, Fleet Command can migrate the workload of that system to another on the same network, ensuring real-time insights are never lost. So managing artificial intelligence at the edge is only as good as your control that you have over it. And if you're able to deploy software and put software updates, and then also have the peace of mind of knowing that your software is resilient so that if it breaks down, it can respin itself or migrate the workload so that you don't ever have to worry about your insights being lost. So I do want to deep dive into security here a little bit, because security is extremely important for every product here at NVIDIA, and it's a big pillar of our organization. We hire the best experts from U.S. intelligence communities and other leading security organizations, always to ensure that our customer and partner intellectual property is protected. So I want to spend a couple minutes talking to you guys a little bit about the Fleet Command security at the edge. So for Fleet Command, security happens in 5 ways. You see them up on the screen here. So let's start on the left here. Content security means that applications hosted in the NVIDIA cloud, this is the NGC I'm talking about, are scanned for malware and vulnerabilities before the application is loaded. And as I mentioned before, you're able to sign the containers that you have, so you always know that every container is secure before it is deployed to the edge. To secure your data flow, all data is encrypted in transit and at rest. And in addition, secure and measured boot protects against system tampering. For data residency, because systems exist in the physical location and sensor feeds are processed locally, you are always in control of where your data exists, and therefore have control to shape your own risk posture instead of relying on partners. And for some organizations, this is extremely critical. Isolation is that your intellectual property in NGC and at the edge is isolated from all other users, ensuring that no one has access to your IP except for you and your team. So if you're loading your application into NVIDIA NGC and you're deploying it, it is only you that has access to that information, always and ever. And then, of course, operational simplicity. A Fleet Command allows you to standardize your deployments, configurations, and application updates. And this makes it easy to identify and remediate abnormalities and vulnerabilities that you find in the system. So that's what our security posture is. And hopefully you guys have a pretty good understanding of what Fleet Command is and what it means and the value that it provides. And I want to spend a couple minutes here and talk about some really cool use cases that we have for successful deployments with NVIDIA Fleet Command. So here is a cool use case with the Keon Group. So Dematic is a subsidiary of the Keon Group, and that manages warehouses and automation systems. And this is at over 6,000 facilities worldwide, so it's a lot. And the goal of Keon and Dematic, the problem that they're trying to solve is that they want to use artificial intelligence to automate every single step involved in the material handling at their facilities. And doing so will increase warehouse throughput and efficiency, which, if you guys are familiar with the model for warehouses and manufacturing facilities, those are the 2 main variables determining the success of a facility, is how efficient they are and what their throughput is. So Dematic has built an application to help automate their systems using the NVIDIA Metropolis application framework. That's what I mentioned before, is all of our application frameworks provide tools for people building applications. They've chosen to use the Metropolis application framework, and the application has been deployed at an incubation facility and is used to help create more efficient packing systems. So where Fleet Command comes in is Fleet Command helps manage this application and other applications like it to help accelerate the process for organizations hoping to adopt artificial intelligence. So if you watched the keynote on Monday with our CEO, Jensen Huang, then you saw this awesome use case video that we created with the Keon Group. If you haven't yet watched the keynote, I encourage you to go back after this session and watch it. The video is really awesome. And the keynote, of course, is just really incredible. The next use case is with Northwestern Medicine and Whiteboard Coordinator. So Northwestern Medicine is a leading healthcare institution in Illinois, and Whiteboard Coordinator is a deep learning technology provider for the healthcare industry. So Northwestern Hospital is looking for ways to automate care and reduce patient contact during tough times, like a global pandemic. To do this, they're working with Whiteboard Coordinator to implement an AI-powered virtual patient assistance voice application powered by NVIDIA Clara Guardian. So NVIDIA Clara Guardian is the application framework here that they're using to help for this application. And this voice-operated virtual patient assistant helps patients by answering questions. It provides information about their treatment, much in the same way a nurse or another healthcare worker would do. And this frees up hospital staff to focus on other patient treatment activities. So this application at Northwestern was deployed and managed at the facility using NVIDIA Fleet Command. With little patient contact, administrators were able to successfully run the application and answer patient questions before a procedure. So we're seeing some really interesting and successful use cases with Fleet Command, being able to manage and scale artificial intelligence at the edge. So as you guys are thinking about Fleet Command, I want to make it clear to you guys that this is available. Fleet Command is available right now as part of an early access program for organizations that are anybody looking to deploy and manage artificial intelligence at the edge. So if any time in this presentation you were like, whoa, this sounds like something that I could use, then this might be exactly the right tool for you. And to learn more about Fleet Command and to apply for the early access program, you can visit the Fleet Command website. You see this website up on the screen right now. Also on that website is the key on use case video, which I encourage you to watch, and a solution brief on Fleet Command as well. So I encourage you guys to head over there and check out all the information that we have there on the site. Even if you're just a little more curious about learning about the solution, you might learn some more about how edge computing and NVIDIA can help you with those solutions. So that's it for the slides I wanted to cover. I wanted to make sure that we had some time to do some Q&A. The first thing I want to do is to thank you, everyone on this call, for listening. And I want to thank you for your time as I go through these slides and talk to you a little bit about the things that I'm passionate about. So thank you guys very much. Looks like we had a few questions come through in the queue. And so to kick off the Q&A portion, I'd like to introduce Eric and Jared, who are product managers here working on edge solutions at NVIDIA. Eric and Jared, are you guys on and available? Maybe a quick introduction.
Yeah, sure. Thank you very much, Troy, for the presentation. So hey, everyone. My name is Eric Bodenhorst. I'm a product manager for the EGX stack at NVIDIA.
And hey, this is Jared Conway. I lead the product management team for EGX, including the product management side of Fleet Command. And yeah, it looks like, Troy, we've got a few questions in the queue. Let me take a look at the first one that's on the list here. So the first question that was getting asked was, what types of applications are supported on Fleet Command? Actually, that's a really great question. I think earlier on in Troy's presentation, he was talking about the different SDKs or frameworks that we have here at NVIDIA, you know, Metropolis for smart cities and smart retail, Isaac for robotics. The majority of the applications that we're focused on with Fleet Command are those applications that are built based on those SDKs. So you could imagine, there's applications for managing live cameras and inference on those types of applications. They're really containerized applications that can be deployed via Helm charts. Eric, it looks like there's a question about hardware for edge use cases. You want to take that one?
Sure. So the question was, what hardware is recommended for edge use cases? And Troy alluded a little bit on this. NVIDIA has the NGC Ready certification program. So that is, NVIDIA works with all the OEMs to provide customers really hardware that is tested and validated for AI applications. And you can actually find the list of servers on the NVIDIA webpage. So you will find it at docs.nvidia.com/ngc ready systems. So just have a look, and you will find the huge list of servers that are qualified to work for edge applications. Jared, I think there's a question around bandwidth in regards to Fleet Command. Do you want to take that one?
Yeah, let me take that one. So that's actually a good question too. So, Troy was talking about kind of the architecture of Fleet Command and how it really marries servers that are running at the edge to a cloud control plane that is able to manage them. So I think there's actually two sides of the answer to that question. And the first side of the question is at the edge, you'll have an application that's running. You'll have software that has to be deployed to it. The bandwidth required there actually has no minimum requirement, I would say. It really comes down to user experience. So initially, a system is brought up from the ground up, installed with a USB, and over the air applications will be deployed from the cloud to it. You can imagine some of these applications can be in the gigabyte size. So the bandwidth required really depends on what the user experience is. If you have a poor bandwidth, a low bandwidth connection, obviously it's going to take a little bit longer for that application to be deployed there. But there's no timeouts or anything like that. So we recommend a pretty standard internet connection for enterprise. 5 or 10 megabits per second will give a pretty good experience on that side of things. The other side of the bandwidth is the control aspect. So when an application needs to be deployed, when an application needs to be updated, monitoring and sending down those updates, that control is actually very, very minimal. So, if you have a decent amount of bandwidth to get the software downloaded there quickly, then you'll have a good experience from a control perspective. I'll jump on to a couple other kind of Fleet Command questions before we move back onto kind of EGX and EGX stack. So I have a question about disconnected environments. Actually, today, we're focused primarily on cloud control, but what we will be working on is, what it looks like to have this totally behind somebody's firewall. We're actually collecting customer input right now to understand what the use cases are and what the best customer experience is. Because the benefit of being in the cloud is speed of innovation, being able to deploy updates, being able to support customers. But certainly we do know that there are some sensitive environments that will benefit from these types of capabilities, but that do need to be behind a customer's firewall. So looking forward to engaging customers on that to learn a little bit more about what their use case is. But today, the main thing is, while we do have cloud connection for being able to do the control aspects of Fleet Command, all the data is resonant to that edge location. I think Troy was talking about, it's part of the security pillars is, the data is resident to the edge location. We're really just passing applications down to it and some monitoring data up to the cloud, which can be actually disabled if necessary, but the data stays resident on that edge location, which should meet a lot of different use cases, which may have required a disconnected environment in the long run. Hey, Eric, there's a question just to cover a little bit more about what what Troy was talking about relative to EGX stack for OpenShift and how they get access to those types of components. Sure.
So we have built the GPU operator, and the GPU operator is really allows you to use GPUs in OpenShift. The operator allows you to manage the nodes, the worker nodes in your OpenShift cluster that have GPUs at a cluster level. And what we've done with Red Hat is we've certified that operator. And that operator, you can actually find it inside the embedded operator hub that sits within OpenShift. So it's very easy to use. Right, it's right there at your fingertips, and it's certified. So we've worked with Red Hat to make sure that it works the expected way. Jared? Anything else, or do you want to take on the next question? I see a couple other questions that I think are more targeted towards you.
Yeah, I'll take those last few questions from the list here. So another really good one about supported GPUs. So Eric had covered this, and Troy had covered this a little bit earlier. Was talking about NVIDIA's NGC Ready certification program and also the NVIDIA certification program that was announced at GTC. Our primary target today is, inference at the edge and, servers that are using the T4 GPU. But we do have, the question is, will there be support for Jetson? And the answer is definitely. We see more and more users looking at how Jetson fits into their overall ecosystem of servers at the edge. Today we have some technical previews of being able to manage and deploy applications on Jetsons, but we know there's a wide swath of embedded devices that use Jetson, and we need to make sure that we get it right. So we are targeting, early next year to have more support on the Jetson side of things, but today our focus is on x86. If you have interest in, the Jetson side of things, when you sign up for the early access program, highly recommend you add some information about your use of Jetson, and we'll be interested in learning a little bit more about what your software stack is there, and what the requirements are for remote management for those particular devices. The next one is about, the next one's actually really interesting. It's to connect the dots relative to one of the announcements yesterday about DPUs, or I guess it was 2 days ago, connecting the dots about DPUs and whether the software could be, just trying to understand this, is will the DPU provide encryption in transit? So yeah, so I think one of the things that we're looking at is how the DPU fits into the overall kind of ecosystem for Fleet Command and for the edge. Definitely we see some benefits that, if a DPU exists on the system, there's some additional capabilities that we could add. Today we don't have a direct line of sight of what that looks like, but you can imagine we're working through many different use cases that the DPU could be used, whether it's managing storage, managing encryption, managing network. We'll be working on those over the next little bit. Last kind of question that I can see here is, can Fleet Command be used to deploy shared storage? And the answer is yes. So I think there's several different use cases relative to storage. Those that can be deployed via the Helm chart. Those are those that need to be set up in advance. We have a couple different paths for how that can be set up. So yes, there are capabilities there that we can use. So Troy or Alice, it looks like we've captured all the questions that we have for today. How do we want to wrap this one up?
Thank you for joining us for this session at GTC. This session will be available on demand in the session catalog within 24 hours. Have a wonderful day, and thank you for joining us.